Hi guys, so we're going to move forward today into section 30-3, which deals with the area of a trapezoid, a rhombus, and a kite. So we're going to start off with the trapezoid. Remember what that trapezoid looks like. To me it always looks like a doghouse, where we're going to have a set of parallel sides that we're going to name the base. And then it's got a couple of other legs that actually don't really come into play for the style of problems we're going to be addressing in terms of finding the area of the trapezoid. We need to recognize that the height, if I could hold on to my pen, is going to be perpendicular to both of the bases. Because the bases are parallel, if it's perpendicular to one, it's going to be perpendicular to the other. And so that's the concept there of height. So our formula for the area of a trapezoid is, and it looks a little bit weird, and especially right now because you can't see anything with my darn document camera, we're going to take 1/2, kind of like what we did with our triangle, times the two bases added together. So like this would be base 1 and that would be base 2. That's what B1 and B2 mean. Times the height. And I promise it will clear up. It was perfect before I started recording. Come on. And now it hates me again. There. Okay, if I try autofocus lock, it just doesn't like me. So this is just what I get to deal with all day, every day. This is why my videos are too long. So I'm going to walk through how to do some of our problems, and I am utilizing our worksheet. I'm going to do the evens. You guys are going to take a look at the odds. So this starts us off with find the area of each. I see a trapezoid and I see another trapezoid. This 12.2 is kind of there to mess with your mind. We don't really need it. We have the two parallel bases and the height that is connecting them at right angles. So for our area, we're going to do 1/2 times the two bases added together times the height of 10. There we go. And so at this point, I promise, guys, somewhere underneath my mess of stuff is my calculator. It's really truly down to typing. If instead of the 1/2 you want to use a 0.5 as you're typing things into your calculator, go ahead. So I'm going to go 0.5, open a parenthesis, 4.8 plus 12, close my parenthesis, times 10. I promise, it's really that simple. That's how this guy works. So our area is 84. Remember, our units are squared because we're talking about two-dimensional analysis on these pictures. And it will focus. So we're going to do the same thing for number 4. Again, we're focusing on our two bases and our height. I think that height is trying to tell me it's 8.4 centimeters. So we're going to have an area of 1/2 times the two bases added together times our height. It will focus. And now I'm going to jump right into my calculations. Oh my goodness. Sometimes if I hit it, it gets better, but it just hates me today. Come on. There. Ish. So 0.5, oh my gosh, times 4.6 plus 11 inside parentheses times 8.4. So you guys can see that on my calculator. You can see my 1/2, which is the same thing as 0.5. The two bases added together, I know they're the bases because they're the parallel sides, and then the 8.4 of the height. So our area is 65.52 centimeters squared. We're going to take a look at the bottom half of this worksheet. So this is a little bit different. These three are obviously not trapezoids. They are rectangles or squares. And it says find the missing measurement. So on number 6, it's telling us the area. Remember, the area of a rectangle or a parallelogram is base times height, length times width, side times side, as long as they're perpendicular. So I'm going to name this question mark x. We're going to take 5 times x. That's our area. Well, our area happens to be equal to 10. So I'm going to solve this guy with my 5x equal to 10. I'm going to divide both sides by 5, and x is 2. That's what we're solving for. So in this case, we're just working our way around to find a missing piece. Now on this guy, I'm kind of feeling like this might be a square, but I don't know because it's not labeled that all of the sides are congruent. So I'm going to take my area equal to base times height, so 24.4. I'm going to call my base 4.7 and my height the x. Oops, where's my whiteout? I can't find my whiteout, guys. Cross it off because I ran out of pencil lead. Do you know how hard that is for a math teacher to run out of pencil lead? So our area is 24.4 equal to a base times a height. We're going to divide away that 4.7. Base height doesn't matter, it all gets multiplied together. My computer was doing so happy there. So 24.4 divided by 4.7, it'll clear up in just a second. Our height is going to be 5.2-ish yards. There. So same thing on this guy with respect to number 10. We're going to take our area of 116.4 and set that equal to 11.3 times our question mark. If we divide away our 11.3, I'm not going to put my calculator under there because it really seems to dislike that. We are looking at 10.3-ish feet equal to our question mark. So that's the first page of our assignment. Yep, there's more. Let's talk about the concept of a rhombus or a kite. So when I think of a rhombus, I think of a slanty square. Well, pretend that's a slanty square with all of the four sides congruent. Oh, that's bad. And when I think of a kite, well, I think of a kite where I've got two congruent little sides and two congruent long sides. So what's really interesting about the rhombus and the kite, I'm really embarrassed by that rhombus right there, but psh, whatever, is that when we connect the diagonals, I'm going to do two different colors here. I'm going to do the same thing in my kite. We get these connections, these diagonals, and what ends up happening is the area for the rhombus and the kite will be the same. Basically, and I'm going to label the yellow one as diagonal 1, so D1, and the pink one is diagonal 2, D2, and it's going to be the same thing in both of our figures. The area is diagonal 1 times diagonal 2 divided by 2. That's not bad. That's pretty dang slick. So, where's my paper? Guys, I'm losing it. I got too many papers sitting in front of me, and I need my paper. So what we're going to do, once I find my paper, I found it. We are going to work our way through this worksheet. You're going to get both worksheets combined, and we're going to figure out how to find the area and whether or not it's a kite or a rhombus. It's actually, it's pretty slick. So, sorry, my dog just sneezed. I miss you guys. I wish we were at school. I'm going to work through the evens. You guys are going to be assigned the odds. So let's take a look at problem number 2. So it's asking the question, is it a kite or a rhombus? The area formula is not going to change, but it's just good to know what we're looking at. When all of the sides are congruent to each other, we're looking at a rhombus. So we need to find the length of our diagonal, and I'm going to kind of utilize my highlighters here. So here's our diagonal, and here's another one. You can see I just wrote on my hand with my pink highlighter. And I lost the cap. I really hope my dog doesn't eat it. That would not be a good day. So we need to take the length of those diagonals. Well, 4 plus 4, that's 8. 5 plus 5, that's 10. So I'm going to highlight my pink, highlight the yellow. It'll clear up in just a second. So we're going to take diagonal 1 times diagonal 2 divided by 2. So we're literally going to take 8 times 10 divided by 2. The 8 is that diagonal of 4 and 4, and the 10 is the 5 and the 5. Well, 8 times 10 is 80, divided by 2 is 40, and we are looking, it didn't tell us any units, so I'm going to say units squared, because it didn't say, like, you know, centimeters or feet or anything of that nature. So we just kind of have to go with what we've got. Sorry guys, I'm searching for my other paper. I can't find it. I am just having myself a day. Oh well, I'll keep going. So let's take a look at number 4. Number 4 is very much the same thing. Hopefully we can recognize that this guy is a rhombus because we've got 4 congruent sides. So we're going to take that diagonal of 10 times this diagonal of 7 and divide it by 2. 10 times 7 is 70, divided by 2 is 35 units squared. Now you might be fussing at me and be like, Bishop, you didn't do any kites. I know, that's 1 and 3. But guess what, guys? You can add, and you can add. You got your diagonals. In fact, this one, here's your diagonal, there's your diagonal, multiply them together, divide by 2. You can do this. So I'm going to scoot down to number 6. We'll deal with kite or rhombus in a bit. It's kind of feeling rhombusy. Notice how all the evens were rhombuses? Rhombi? I think it's rhombi. So here's our task. It says the area of this shape is 32 inches squared. Solve for x. Well, we need to take that diagonal, which is x plus x, or 2x, and then this diagonal, 8 plus 8, which is 16. If we multiply the 2 diagonals together, divided by 2, it'll give us the area, which is 32. We can solve for that. 16 times 2 is 32x, divided by 2. Well, 32 divided by 2 is 16. If I divide that away, x is 2. We just solved for x. X is 2 inches. Now if you're like, are you sure? Well, I hope so. 2 plus 2 is 4. That would be 1 diagonal. Times 8 plus 8, which is 16, divided by 2. That gives me an area of 32, which matches the area. You guys are going to be doing the same thing here. In your rhombus, you'll be provided the area. Your task is to solve for diagonal. Times diagonal divided by 2 equals area. You can do this. Hey, my video is actually going to be under 15 minutes. I'm really excited. I'm so excited that my camera is now completely focused when I'm not trying to do anything. I miss you guys. I hope you guys are doing well. I need to go find the cap to my pink highlighter. It's somewhere on the floor. My dog is probably playing with it. Strange. Take care of yourselves. Bye.